Hello guys, welcome back to my channel. Today we are going to introduce the Gaussian integral. Okay, this is a crazy things. Okay, so in solving this Gaussian integral, we are going to solve in 12 different way. Okay, this is first proof. Then is using polar coordinate. Okay, so okay, let's get started. So our Gaussian integral is nothing but the integral from 0 to infinity e to the negative x square dx. Okay, this integral is what we call the Gaussian integral. Now let me call this I. Now we are going to square. Okay, so I square is nothing but I times I, right? So that one I is this one. Then is I times the integral from 0 to infinity e to the negative x square dx, which is integral from 0 to infinity I times e to the negative x square dx. So this I is nothing but this one. Okay, so which is the integral from 0 to infinity, and this I is this integral itself. So the integral from 0 to infinity e to the negative y square dy times e to the negative x square dx. Why we choose this y? Because in definite integral the properties this, if we change these variables, it will not change this integral. Okay, so using property 1 of definite integral, you can check it out there. Okay, changing this variable into any variables will not affect this integral. Okay, so that's why we are changing it into y. Now taking these two together, I square is double integral from 0 to infinity e to the negative, so negative common, so x square plus y square dx dy. Okay, here this is the one that we are trying to change it into polar coordinate. Okay, now changing to polar coordinate, how? So in the video I think I have done, then is x square plus y square is equal to r square. Okay, in terms of polar coordinate, so x square plus y square is r square, and dx dy is r dr d theta. Okay, so this is already proof, and this also already proof. Okay, you can look up that. So why we are doing this one is that I'm trying to prove this one. Okay, the Gaussian integral, I'm trying to calculate the Gaussian integral. That's why we need this one and this one, so that's why I'm doing it first. Now if you change into polar coordinate, so okay, let's change it. Okay, now I square is integral, this integral, let's neglect this two, e to the negative, and x square plus y square is r square e to the negative r square dx dy is r dr d theta. Now if you say this, how come? Okay, you may wonder. Okay, let's see here the polar coordinate, drawing one triangle. Okay, this is theta and this is r. Okay, in terms of what, this is x and this is y. Okay, so if you see this x square plus y square, this one lies in the first quadrant. Okay, this is what we call the first quadrant. That means this part. Okay, this one is first quadrant, and this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay, so this one x square plus y square, if you put negative also, it will become positive, both of them. So that means x square plus y square lies on the first quadrant, in first quadrant, or are positive. Okay, in terms of trigo. Now we are going to see this bound. Okay, upper limit and lower limit one. So for, since we are changing from this x square y square to polar coordinate, right? So we need to change the upper limit and lower limit also. Now let's consider for r. So this is what we call r, right? So here let's take one of them. Let's say this is r. Okay, this is for r, let's say. So this r is start from 0 to infinity, so this is the origin 0. So this r I can produce it up to infinite times like this. Okay, that's why this upper bound and lower bound will not change here. Okay, now let's see at theta. This one, let's say this for theta. Okay, the angle theta. So the angle is from, since 0 to infinity, this one lies on this first quadrant, right? I mean whole of this one. Okay, it lies on this plane. You can say xy plane, right? So this theta, this will start from this 0, and then it will can go up to pi by 2, right? Can go up to pi by 2. This is pi by 2. Okay, this is 0, this is pi by 2, this is pi 3 pi by 2, right? So since these two integral lies on this first quadrant, so the angle will be from 0 to pi by 2, I mean, right? So it lies between 0 and pi by 2, the angle, and this r can be extended up to infinite times. Okay, that's why this will change to 0 to pi over 2. I hope you are clear with that. Okay, now we are going to evaluate this two integral now, which is the integral from 0 to infinity r e to the negative r square dr, and integral from 0 to pi over 2 d theta, right? So separating them. Now put r square equal to y implies that 2r, if you differentiate 2r dr is dy. Okay, for this integral one. Now I square becomes the integral from 0 to infinity. It will not change. Okay, upper bound, lower bound. If r is equal to 0, then y is 0. If r is infinity, y is infinity. So e to the negative y, e to the negative y, r square is y. And then this r dr is nothing but here r dr. If you find out here, r dr will be dy by 2, right? So it will be dy by 2, and integration of d theta is theta, right? From 0 to pi over 2. Then you get, now if you substitute here, pi by 2 minus 0, right? Times this 1 by 2 coming out here, then the integral from 0 to infinity e to the negative y dy, right? So I square is pi by 4, right? Pi by 2 minus 0 is pi by 2. Pi by 2 times 1 by 2 is pi by 4. Now integrate this one, it will be negative e to the negative y from 0 to infinity, which is pi by 4, negative e to the negative infinity plus e to the negative 0, which is pi by 4, times 0 plus 1. Okay, e to the negative infinity is 0 here. E to the negative infinity is same as 1 over e to the infinity, so which is 1 over infinity, and this will change tends to 0. Okay, that's why this part is 0 plus 1, so it will be I square is pi by 4, implies, now taking the square root both sides, okay, then you get I is the square root of pi by 4. Here we are neglecting negative, okay, negative 1. So actually when we are taking this square root, okay, we are going to add this plus minus a, right? Because this is a quadratic, so if we have two roots, right? But we are going to consider only the positive part. Okay, that's why this one pi by 4. So 4 is nothing but 2 square, so square we get here, you will get square root of pi by 2. So or integral I, this one, is nothing but square root of pi by 2. Okay, therefore the integral from 0 to infinity e to the negative x squared dx is the square root of pi by 2. Here I is greater than 0. Okay, since I is greater than 0, so our integral, this one, will be square root of pi by 2. Wow, amazing, right? So actually this Gaussian integral we cannot evaluate in another way, meaning using substitution or integration by part, like that, right? We cannot use them. Okay, we cannot use to calculate them to get our results, so we are using this polar coordinate. So this integral is done by this guy. If you take probability, okay, theory of probability, you will have this guy name, how to pronounce, Poisson or something like that. Sorry, okay. Poisson. I'll just call it Poisson. Okay, so this integral is due to this guy. Okay, he used this polar coordinate to evaluate this Gaussian integral. Okay.